My name is Ian Hillway, and this is the Overkill control box. I designed this for three-dimensional space flight for the game Elite Dangerous. My whole goal for this was to be able to have three-dimensional control of a spaceship, along with various control buttons. This entire thing is 3D printed, except for the buttons and a control board inside that runs the whole thing. The thing I wanted to talk about, though, regarding this is I didn't just start with this. My first control box looked like this. And at the time I started, I really didn't know anything about 3D design, very little about 3D printing. I wanted to solve a problem, and that was I had a joystick in one hand, and that was great for, you know, pitch and yaw and turning. But I also needed a way to move my ship front, back, left, right, and up and down. And a lot of the control devices out there are pretty pricey. I just had like a $20 joystick. And I didn't want to spend a whole bunch of money. And, you know, over the price of this, the course of this, I have spent probably more money than I wanted to. But I think I ended up with something that is a lot better. But back to where I started. When I started this, I really didn't know anything. I just went to an electronics shop, and I bought this box, and I bought some buttons. Just little buttons. Like this, two connectors on the back. It really doesn't matter which way power flows through. It just, when the button is pressed, it completes the circuit, and that goes to the computer. I've got up and down here on the side. I'm going to open it up so that we can look inside and see what's going on in here, because for this, it's actually pretty simple. It's a lot of cables in there. When I open it, don't be surprised. It looks like there's a lot going on, but it's really not that bad. All the work is being done by one little processor board in there. That's right here. And I got this online, and I think it was like $20, something like that. And it comes with these cables, and one end is set up to plug into the board with a little connector, and the other end has individual connectors for the little parts of the button there, and they just plug in like that. So this is USB. It has a little USB cable connector here, and this goes out to the computer like that. And all it does is it converts the button presses into joystick button presses. And then it's got a cable here for, you know, an actual joystick, like an arcade joystick, not an analog joystick, but a joystick with buttons, up, down, left, right. And that is connected to a little 5-way switch here that actually has little buttons. And that's just hot glued onto the top of this. And that's pretty much the basics of it. So each one of, I just drilled holes in the box, and each one of the little buttons just goes through, and then there's a little ring you tighten it down with on the other end that just unscrews, right? So you just put it through and you tighten it down. And then it's stuck to the box, and then all you do is you find the connectors, right? And you connect the connectors onto the little nubs on the back end, pins, whatever you want to call them. And the other ends pop in here, and that's pretty much it. There's an extra one here that I used to power the LED on this one, so that when it's on, the LED comes on. But, you know, it doesn't have to be anything fancy. You can make something like this. I think the board was about $20, and the cost of the switches and it comes with pretty much all the wires you need. You don't need any soldering. You just put it all in the box and tuck it all in there somehow so that it fits, and then that's it. And the board's already pre-programmed so that it just functions as a little joystick. And it may not look fancy, but it works. And the first addition that I made to it was a little cardboard wrist rest thing that I just taped on there with blue tape. And so then I could use this for forward, back, left and right, up and down. And I had, some buttons at my disposal. And different buttons have, different characteristics. Some are softer, some are firmer, some have a click when you press them, some don't. Toggles, whatever. All it does is when you press the button, it makes a current go through that pin, and it activates it in the joystick. And you've got a control box. And you can make one of these pretty easily, and they're really hard to mess up. So if you've ever thought about doing something like that, you should give it a try. It's pretty straightforward, and the parts are inexpensive and easy to hook up. And you can have something that's functional, and you can put in anything here. You can put in a bunch of toggle switches. You can just have this whole thing full of toggle switches. You're limited to the board you have. So this one had, 1, 2, 3, 4, 5, 6, 7, 8, 9 pins on it. So, I could only have, 10 buttons on this one. But there are other methods that are more sophisticated that give you more buttons. And as soon as I had this working, and 2 more. So that was 12, I believe. As soon as I had this working, of course, in the normal human method of being, I wanted more, like we all do. I wanted more buttons. So I started 3D designing, and I ordered online a Teensy 3.2, which is a small microcontroller. And I designed a board built around these little Overkill switches, and a little joystick for forward, back, left, and right. Still got the button here for the up and down, my 5-way switch here, and I played around with buttons that were facing forward here, so that I would have as many as possible. And I ran into a lot of problems with this one because these little buttons, they look pretty disorganized. The caps turn. The soldering did not go very well. A lot of small pieces to soldering. I was still figuring it out. Some of the buttons didn't even work. I ended up trying to hot glue some of them in, and hot glue does not play nice with PLA, which is what this is printed in. And so overall, I learned a lot from it, but I didn't really like the look. The joystick in the middle takes up a lot of space, and I was looking for a better solution. Ergonomically, it worked pretty well, but it wasn't working well enough. So then I moved on to the next step, which, and this is incomplete, it's missing some parts here. It's built around a Let's Split board with, again, a Teensy 3.2 on it. It was designed for a different kind of board, and I had to do some kind of creative wiring on the other end to get it to interface right. But it provided a nice rigid board, and it fit right in to this. It looked really, really nice and slick. This space here in the middle, I left a key out because I plan to add in this, which is a PSP slider. It takes up a lot less space, and it's analog, and you get forward, left, forward, back, left, and right, so that this could just pop in here, right? And then I have the same kind of thing going on that I did with this, but it's a lot more tidy. And this doesn't have any of the keycaps on it right now, but they just pop on. I don't know if any of you have ever taken a keyboard apart, but they just stick on like that. So I never really got this one working. because, and it's got this little cover that goes on here. It was going to have this kind of joystick for the thumb, and a little these buttons here in a condensed setup here that would just fit right in. And I never really got it working right because the way that the Let's Split board works, it has circuits where the switches are all in line, and depending on which one you press, apparently it gives a different amount of resistance to the board, and the board figures it out. And since I was trying to program it on a different board than it was designed for, it just was a little bit beyond my level of expertise. So I decided that I needed to move on yet again. And that's when I got to this. So this has, instead of the Let's Split, it just has a piece of plastic here that's printed that holds the keys. It's got a little holder here for the PSP slider. It's got the mini panel that I was just talking about here with the Overkill buttons here and the 5-way switch that's been on there since the very first one. That's the same switch that's here. You know, it just, well, that's glued on, so I can't pull it off. You know, it's just built in a little bit better here. And if we look underneath here, the whole thing is designed to be able to come apart pretty easily. So if we look inside, you can see, you know, we got a wire soldered here for our ground, and we've got pins there, and you've got the pins in here on this board. This was originally set up in this version using a board from Adafruit that's designed to fit in an Altoid mince tin, which was a really good size, and it provided a nice firm backing. There are some traces here that are connected, and I had to kind of scrape little grooves through them to cut them apart so that it would work right. But I really liked how it worked. In the end, I decided to not go with that because I wanted to have something that was easier to 3D print, and I wanted to try and minimize the amount of things that people had to buy to put this together. Originally, I had one solid back piece, and you had to kind of pop out, you know, a thing there so that you could pull it open, and it was kind of held in place with these 3D printed plastic pins that were a part of it, and you can see really kind of a pain to get apart. And inside it's kind of a mess. You can see the TNC 3.2 there, and you know, it was difficult to get the joystick lined up exactly right when you were putting it together, and a mess of cables, and it was just not user friendly at all, which is why when I moved on to the next stage, I moved on to this kind of 2-compartment setup with holes, you know, that go in between for the wires to run, and a hole for the cable out. And this one's been kind of ground out because I made adjustments as I went. And you can also see for this one, it has a low wrist setting, and I found I had to reach a bit far to hit these keys at the very back. So for the final version, I raised the wrist a bit so that it presses your whole hand forward a little, leans it forward, and it's easier to reach those buttons in the back. I mean, sometimes you have to move a little bit, but most of the keys are pretty easily reachable, including these, without having to, you know, move your hand much. The way I do it, I have my middle finger on the slider, you know, and then I can hit all the keys around it. So I can be moving the ship, right, and still activating the keys I need. And the most common ones, my throttle, they're all right here. and the other things that I need less frequently are farther around the outside. And Elite Dangerous, this is helps me control my sub menus and things like that. So this is all my flight controls, and this is my menus. And that's basically it. But I didn't get straight to here. Remember, you know, I started way back here. And it was just a couple of buttons and a board that I didn't need to program inside that I got off of Amazon. That was pretty much all just plug and play. You just stick the wires in and hook it all up and plug in your USB to your computer, and it just goes. And I didn't really need to know much of anything for that. So don't think that you have to be able to do this from the start, because everybody starts knowing nothing. So don't be afraid to experiment. And I learned a lot making this. I built this in SketchUp to do my 3D design, which is free. And built it printed it on my 3D printer at home, which I got off Craigslist used. And that's it, with just some buttons and a Teensy 3.6 inside. I switched from a Teensy 3.2 to a Teensy 3.6 because the 3.6 accommodates more inputs, and so it gives a lot more flexibility. So that's basically it as far as just the overview of what this is and where I started, and the only advice I have for people if they've been thinking about doing something like this is be brave and start small and learn a little something and build on it, and that'll get you from this to this.